Alright, so in this system of equations, I have x squared minus y squared is equal to 28, and x times y equals 48. So I'm given two equations. Let's just say that this is equation 1 and this is equation 2. So what I want to do is find the value of x plus y. So what is the value of x plus y? And finding this is fairly simple when we find the value of x and the value of y. So to start, what I'm actually going to do is I'm going to use my second equation here. So equation 2 is x times y equals 48. And what I'm going to do is I'm going to solve for one variable in relation to the other. So it doesn't matter which one, but for this case, I'm going to solve for y. And to solve for y, I have to isolate it, meaning I have to get rid of this x by dividing both sides by x. So I get y is equal to 48 over x. Now, using this equation, I can plug this back into equation 1. So equation 1 is x squared minus y squared is equal to 28. Now here we got y is equal to 48 over x. So if I plug this in for y, I get x squared minus 48 over x squared is equal to 28. Now I can substitute the 2, so I get x squared minus 48 squared over x squared is equal to 28. Now I'm going to multiply both sides by x squared. So now, for my left-hand side, I have to distribute the x squared. X squared times x squared is x squared squared, or x squared to the power of 2. Now I have this minus 48 squared over x squared times x squared. These two x squared cancel out, so I just get 48 squared. And now this is equal to 28x squared. Now I'm going to subtract 28x squared on both sides. So I get x squared to the power of 2 minus 28x squared minus 48 squared is equal to 0. Now I'm going to set u equal to x squared. So I get u squared minus 28u minus 48 squared is equal to 0. And now I can solve this by completing the square. So I'm going to add 48 squared back. And now I get u squared minus 28u is equal to 48 squared. Now I'm going to add this, so negative 28, or we can say just positive 28. I'm going to add this divided by 2 squared on both sides. And if you guys don't know what completing the square is, you have to go watch a video on it. So I add this on both sides. I add 28 over 2 squared on both sides. And 28 over 2 is 14, so I get u squared minus 28u plus 14 squared, which is equal to 48 squared plus, again, 14 squared. And now the reason I did this, the reason I used completing the square, was because now I can factor this out. This turns into u minus 14 squared, which is equal to 48 squared, I'm going to rewrite as 50 minus 2 squared, and 14 squared I'm going to rewrite as 10 plus 4 squared. Now from here, u minus 14 squared is equal to 2500 minus 200 plus 4 plus 100 plus 80 plus 16. And now if we add these up, we get u minus 14 squared is equal to 2500. And if we take the square root on both sides, we get u minus 14 is equal to positive or negative 50. So we get two equations. Now we get u minus 14 is equal to positive 50 and u minus 14 is equal to negative 50. So u minus 14 is equal positive 50, I get u is equal to 64. And u minus 14 is equal to negative 50, I get u is equal to negative 36. Now remember how we let u equal x squared. So this means that x squared is equal to 64 and x squared is equal to negative 36. Well, we can't have a number squared equal to a negative number, so this is wrong, meaning that x squared equals 64 is my only proper equation, and if I take the square root on both sides, I get x is equal to positive or negative 8. So these are my two solutions to this problem. And I know that I said this wasn't work, but there actually is a way we can use this to find solutions, not real solutions, but imaginary solutions. So to do that, what I'm going to do is x squared is equal to negative 36. If I take the square root on both sides, I get x is equal to square root of negative 36. And the square root of negative 36 is the same thing as the square root of 36 times the square root of negative 1. Now the square root of negative 1 is the same thing as I, so I get x is equal to the square root of 36i. And the square root of 36 is the same thing as positive or negative 6. So I get x is equal to positive or negative 6i. So these are another two solutions. And these aren't real solutions, but these are imaginary solutions, which still count as solutions to this problem. So my four solutions are x equals 8, x equals negative 8, x is equal to 6i, and x is equal to negative 6i. Alright, so in this problem, I have 5 to the power of x plus 5 to the power of x plus 5 to the power of x plus 5 to the power of x is equal to 1,000. So for my solution, I'm going to first start by factoring out 5 to the power of x from my left-hand side. Because as you can see, we have 4 of the same terms on my left-hand side, and the easiest way to go about solving this equation is to factor them out. So I get 5 to the power of x times, well, 5 to the power of x divided by 5 to the power of x is simply 1, so I get 1 plus 1 plus 1 plus 1 is equal to 1,000. And now 1 plus 1 plus 1 plus 1 is 4, so I get 5 to the power of x times 4 is equal to 1,000. Now, we want to isolate x, so I'm going to divide both sides by 4. So then these two cancel out, and I get 5 to the power of x is equal to 1,000 divided by 4, which is 250. So from this large equation here, we got up to an equation that is significantly smaller. So we have 5 to the power of x equals 250, and just at first glance of this equation, we can tell that x is not going to be a whole number because we have 5 squared is 25, 5 to the power of 3 is 125, and 5 to the power of 4, this is going to be 125 times 5, which is 625. So the value of x is somewhere in between 3 and 4. Now to actually find the exact value of x, not just an estimate, what we're going to do is rewrite 250 as 25 times 10. And the reason I did this is because 25 is the same thing as 5 squared. So I get 5 squared times 10. And now I'm going to take the log on both sides. So I get log of 5 to the power of x is equal to log of 5 squared times 10. And this is the same thing as, well, log a times b is equal to log of a plus log b. So log 5 squared times 10 is going to equal log of 5 squared plus log of 10. Now, if I have something in the form log a to the power of b, I can move this exponent b to the front. So this is going to equal b times log a. So in this case, I have log 5 to the power of x. I can move x to the front. And I have log 5 to the power of 2. So I can move 2 to the front. And I get x times log of 5 is equal to 2 times log of 5 plus log 10. Now I'm going to divide both sides by log 5. So then these two cancel out, and I get x is equal to 2 times log 5 plus log 10 over log 5. Now, if you guys already know, log 10 is equal to 1. So now I get x is equal to 2 times log 5 plus 1 over log 5. And this is the same thing as 2 times log 5 over log 5 plus 1 over log 5. Now these two log 5s cancel out, so I get x is equal to 2 plus 1 over log 5. And although this is an exceptional answer, I want the exact answer, so I'm going to find the value of log 5. And log 5 is equal to 0.699, meaning 1 divided by log of 5 is going to equal 1.43. So 2 plus 1.43 is 3.143. So I get x is equal to 3.143. And this is my answer to this problem. And remember how we already said that x was going to be somewhere in between 3 and 4. So this proves us right.